Okay, so today we're going to talk about analyzing graphs and go into like a short worksheet question. So I got some silly graphs to start that we're going to talk about and just talk about how do we analyze data. And we're going to talk about what's good and bad about these graphs based off what we've learned this week about graphs. So this graph, what we notice, it has a title and it has a key. It says what I can't, and it's I can't even 100% of the time. So something to note, there's really no need. There's no real good labels here. That's kind of the biggest thing about this one. We look at this one. Remember, on your x-axis, you have your independent variables, what you're changing. Here it's your seat versus the guy in front of you seat. On an airplane, right? The title is giving us a nice description of what's happening. Degrees, I'd maybe have like an angular degrees here, something maybe a little bit more specific. And what we notice is that your seat only tilts back like 3 degrees, right? But this person goes 90, and actually, like, this is maybe not the best thing to go here. Maybe they could say it like goes an additional 90, but this person's laying down straight. So that's kind of a funny thing here. You got your independent, what you're changing, your dependent, what you're measuring, the degrees, and then you kind of have some observations that you can make, right? Like, okay, their seat goes way down. And what are some conclusions that we could draw? Maybe it's like this guy's seat is broken and yours is working correctly, or yours is broken and theirs isn't working correctly. But we make some observations. The guy in front of you, chair, goes 90 degrees. Yours only goes a couple. That's an observation based on this. So procrastination of homework. We got level of worry. That's what we're measuring. Time is what we're changing. If you were to look at this, when given after school, 8 p.m., 2 a.m., morning before school, these are not consistent scales. So that's maybe like the biggest thing about this one. And then level of worry, as you're reading, these are pretty subjective measures. Screw this, I can wait. I had something else to do. I should really do that homework. I should really do that homework. And this one's like, oh crap. So as you can see, like, there's some obviously in a funny graph like this, there's some things that are not very good. But as I can see, is from when it's given until 8 p.m., my level of worry increases slightly. And then from 8 p.m. to 2 a.m., my level of worry goes down to like nothing. I'm not even worried about it. And then from 2 a.m. until the morning before school, my level of worry increases very rapidly. And what are some conclusions you could draw? Maybe this isn't the best student in the world. The student is very good at procrastinating. There's a lot of different things that you could draw from this. But in general, there's just some nice observations about the graph and then conclusions that we can draw from it. So a lot of the ACT for the science section is based off of this. So this table, we have 4 graphs we're going to look at here. We're going to fill out like the first 2 together, and then 3 and 4 you're going to do on your own. And then, like we'll go from there. And I might talk through this. I might not top it out, but we're going to look at 3 and 4 together, and then your quiz today is going to look at it. So type of chart here. This is a scatter plot. What I see is a line going down. So I'm going to get my pen out here. I really wish that this would allow me to type. So I got a scatter plot. I'm just going to put SP. It has a line of best fit here. Notice how it's not a line graph because they aren't connected. Independent variable, this is grams of fertilizer. That's the thing on the x-axis. That's what I'm changing. What I'm measuring is time to bloom. I'm just gonna put bloom just because it takes less time. Observations. What are the things that we could see? Is that like in general, there's what we call an indirect relationship. That's where an indirect relationship is one that looks like this, where the line of best fit, the data tends to go that direction on a plot. That's what indirect is. Direct would be this way. So if we had one that looked like that, that would be direct instead of indirect. So observations, like if you double your amount of fertilizer from 2 to 4, your bloom time goes from 25 days to roughly 15 days. If you go from add 2 more grams, 4 to 6, you go from roughly 15 to 7.5. So you see kind of a linear decrease here. There seems to be pretty strong indirect. So what we're saying, possible prediction, if, say something about your independent variable, if you increase the amount of fertilizer per week, then your time to bloom goes down. Okay, so conclusions, fertilizer is really important for bloom time. Those are the types of conclusions that you can draw from the data. Okay, let's look at a second graph here. So type of chart, this one is a line graph because it's connected. Okay, so I got, and it's actually like a double line graph because I got 2 lines. Independent variable is the year, that's what I'm changing. And what I'm measuring is average ACT scores. So I'm just put ACT. Okay, observations. There's a trend between ACT and GPA. Okay, so observations, like as you see, there's a strong relationship between ACT scores and GPA. Okay, that's one observation. In general, as one goes up, the other goes down. So there's no clear relationship here except for like ACT and GPA are correlated. Possible predictions. If you change the year, then your GPA and ACT scores are going to change too. So like maybe something happened. Say this was a city that was hit by tornadoes really bad in 2011 during the school year. So GPAs dipped because students had just less access to utilities and things that they needed in order to be safe and have a good year. And because of that, their ACT scores also went down. Okay, or maybe this year, like the school decided to really emphasize certain aspects with students, like test preparation, and those are assignments and things of that nature. So not only were their GPAs improved, but their scores were also improved. These are some conclusions that we could possibly draw from here. Observations are pretty simple. They're impartial. From 2008 to 2011, both GPA and ACT scores went down. From 2011 to 2013, they both went up. From 2013 to 14, they both went down. Relationships is they're both correlated, so you could say that they're both correlated. GPA and ACT score seems to be correlated, and conclusions is some of those other things that we can talk about going into causes. Okay, so graph 3 here, we got number of people that like Italian food, so we got type of chart, independent, dependent, and so forth. I want you to answer these questions on your own. You can do it on some scratch paper, just do it mentally. And when you're ready, you can go take the quiz. And same thing here with graph number 4 between tuition and student enrollment, a very simple graph as well. Type of chart, and so forth. So 3 and 4, that's the last thing here. Then you're done for the day.